Good morning, children. In the previous class, I had explained to you about the graphical representation of motion, in which we had taken up distance time graph and velocity time graph. Am I right? The slope of distance time graph gives you the speed, and the slope of velocity time graph helps you to find the acceleration. Now, let us take up three important equations which you come across when objects are moving in a uniformly accelerated motion. There are three important equations which you come across. Remember, so far you have come across two equations, two formulas. One is V is equal to S by T, and the second one is A is equal to V minus U upon T. Now here there are three more formulas which you will be learning. V is equal to U plus AT, S is equal to UT plus half AT square, and twice AS is V square minus U square. These are the equations which are describing certain relation. The first one, that is V is equal to U plus AT, describes the velocity time relation, means relation between velocity and the time. Okay, here velocity and the time relation is explained over here in the very first equation. Second equation shows position time relation. Position means S is distance, position. Position and the time relation is explained over here. In the third one you have position and velocity. Okay, in the third one you are having position and velocity, because S is there and velocity is also given over here, timing is not there. So these three are to be derived, and here it is said by graphical method. So you derive the equations by graphical method. For that, the very first equation which we derive is equation for velocity time relation. Now for this relation, this is a graph which is to be considered. An object which is moving in a uniform motion. Okay, so this is velocity versus time axis. An object, when it starts moving, it will be at an initial velocity u. Okay, so A is a point from where it is starting the movement. At that time timing is 0, and its velocity will be whatever is the velocity over here, that is the initial velocity u. Then it slowly has an accelerated motion, that means steadily the velocity increases with time and it reaches a point B. At that time its velocity is v, final velocity. This change from u to v takes place within a time period. The time period we consider as a time t. So your graph is this. Okay, you have to now find a relation over here. So how will you try to find the relation? For that, I have explained it over here in the writing part. Okay, see, this is how the graph can be redrawn. Velocity versus time axis. At a point A, the initial velocity is u. The vehicle starts picking up the velocity, that means acceleration slowly picks up, and then it reaches a point B. At that time its velocity is v. Okay, now you have to find out the first situation which you are talking is velocity time. Now in this particular graph, the BC, complete BC would be, the number corresponding to B will be v, and the number corresponding to C is starting point O, that is 0. So BC distance will be equal to v minus 0, that is v. So BC will be final velocity v, and CD, D corresponds to U. So CD will be U minus O, that is U minus 0 will be U. So CD will be equal to initial velocity U. Okay, so if I want to find out BD distance, it will be BC minus CD. BC full is V, CD is U. If I subtract from V U, I will get BD distance. So BD is equal to BC minus CD, that is V minus U. Okay till here? Now what about OC? This movement is taking place within a given time t. We don't know what time, but we assume it to be a time t. So OC distance will be time t. OC and AD, they both are equal. They are opposite sides of the rectangle. So AD is also t and OC is also t. So now in this part, If you remember in the previous video I told you the slope of velocity time graph gives you acceleration. So this is the slope AB. So slope AB will be equal to BD upon AD. Am I correct? BD upon AD. The BD will be equal to what we wrote? V minus U. AD will be equal to what? It is equal to OC, that is T. So BD upon AD is BD upon OC, that will be V minus U upon T. So if you cross multiply, you get AT is equal to V minus U. This is your first relation. V is equal to U comes over here. V is equal to U plus AT, velocity time relation. If in the exam they ask you derive for velocity time relation, then you have to draw this graph and explain it over here. Is that point clear or not? In your textbook, if you want to see where the explanation is, your explanation starts over here. Consider the velocity time graph of an object which is moving under uniform acceleration as shown in the figure. So this figure is to be drawn, which I already showed it to you just now. Okay, and then in the writing part you will write what is given in your text. Okay, the same writing part will do. This is the writing part which is given over here, that as shown in the figure. Okay, so now initial velocity is U corresponding to A, then it slowly increases to V, that is point B, which I told you earlier. So velocity change will be A. Okay, now the final velocity is written. All these underlined portion are to be written down, and from here onwards you write it till this part. See, so this is your equation for velocity time graph. Okay, now the second one is which one given to you? It is going to be position time graph. The second one is position time relation. So for position time relation, again the figure will be which one? The same graph. This is the same graph for all the three situations. Graph will not change. But what will change is position time means position is to be found out with respect to time. Now another thing which you remember in my previous video, I told you that under the graph the area is said to be the distance covered or the position. So this is the graph. Area under the graph will be OABC. What is this figure called? You know, it is a trapezium having one pair of opposite side parallel, the other opposite side is non-parallel. That is a trapezium figure. So here it's a trapezium OABC. So if you find the area of this trapezium, it will be the distance covered by the body which is moving from A to B in a given time t. So S will be equal to OABC, area of OABC. OABC is trapezium, I told you, but this trapezium can be divided into two different shapes. One is a right angle triangle and the other one is a rectangle. Because we have drawn a parallel, therefore it becomes a right angle triangle ABD, and OADC becomes a rectangle. Clear? So area of triangle plus area of rectangle will also give you the complete trapezium. So here area of rectangle here and the triangle. Triangle formula is half of base into height. The base over here will be AD and the height is BD. So half of AD into BD will be area of the triangle, and area of this rectangle will be length into breadth. Length into breadth is OA and OC. Where is it? OA and OC, length into breadth, or you can take AD and CD, any one you can take. So that I have written over here half of base into height and OA into OC. Now substitute the values. What is AD value over here? AD is T, time period T, isn't it? So half of T. What is BD value which you have already derived earlier, if you remember? V minus U. So BD part I wrote V minus U. What is OA and OC? OA is U and OC is T. So it will be U into T. So half of this UT comes to first I have written UT plus half T V minus U. Now this V minus U can also be written as AT. Why? Because in the previous equation, if you remember here, V minus U is equal to AT. Can I write that from the previous equation? Yes. So we put it over here. V minus U, I put it as AT. So now if you open this bracket, you will get UT plus half AT square. This is your very important second formula of uniformly accelerated motion, which is derived by taking the complete trapezium, and in the trapezium you are dividing into two figures and then taking the formulas of the area, substituting the value, and then you get the answer. Am I clear? Now the third situation is the area of the trapezium itself, that is position velocity. For that you take the area of the trapezium itself. Trapezium is OABC, which I showed you earlier. OABC is a trapezium. Now do you know the formula to find the area of the trapezium? It is sum of parallel sides. Kaun hai parallel? OA and BC are the parallel sides. Sum of parallel sides, half the sum of parallel sides, okay? It is half the sum of parallel sides multiplied by perpendicular distance. OC is the perpendicular distance between the parallel sides. ये दोनों parallel sides हैं और ये perpendicular distance between them है. This is non-perpendicular distance, this is perpendicular distance. So the formula is half the sum of parallel sides multiplied by perpendicular distance. So OA and BC will be the U and V value. OA is U and BC is V. Remember, OA is U and BC is V. And OC will be T. So that is written over here. Half of U plus V into T. That is half T U plus V. Now the T value, again from the first equation, can I take up? First equation says that A is equal to V minus U upon T. So if I take the T over here, the A comes down. So T is equal to V minus U upon A, can I write? Here also you can say T is equal to V minus U upon A. So this first equation, the T value is taken up and substituted over here. Half, in place of T I wrote V minus U upon A, and this is V plus U. Now V minus U and V plus U will be V square minus U square, difference of square method, and 2 into A will be 2A. So V square minus U square upon 2A. So S value will be equal to, S means distance, will be equal to V square minus U square upon 2A. This is the third important ratio formula to find out for position velocity graph. Understood or not? So this is how you work out the three. All the three may not be asked in the exam together. This is given on your page 108. The full thing is given. This is position time relation, okay, which is explained over here. And then you have the position velocity relation. Clear till here? यहाँ तक समझ में आ गया? Okay. So now after this you are having the illustrations which are given. So let us take up illustrations one by one. What is this illustration given over here? 8.5. A train starting from rest attains a velocity. Now starting from rest means what? Initial velocity is 0. So train is starting from rest, its initial velocity therefore is 0, and then it is attaining, it is moving at a speed now at 72 km per hour. In 5 minutes में वो speed पकड़ लेता है. Assuming that the acceleration is uniform, you have to find the acceleration and the distance traveled by the train for attaining this particular velocity. So we will put down the data in this manner. Initial velocity is 0. Final velocity is 72 km, which will become 20 meter. How did you convert it? Remember? Multiply 72 by 5 by 18. And timing is 5 minutes means 300 seconds. So A is equal to V minus U upon T. Acceleration find करना हो तो. So 20 minus 0 upon 300, that comes to 1 by 15 meter per second square, because it's acceleration, correct? Next you have to find out is the distance, position. So position you can use any formula. S is equal to ut plus half at square, or S is equal to v square minus u square upon 2a. I have taken v square minus u square upon 2a. V value is 20. U is 0. So 20 square minus 0 square upon 2 into 1 by 15, which is already calculated. Okay, you already calculated this value 1 by 15. So that value is substituted over here. Here, A value which you got, that you substituted over here. So 20 square is 400 upon 2 into this 15 will go in the numerator because it is a fraction in the denominator. So 15 goes up, 400 upon 2 will be 200 into 15, 3000 meter or 3 kilometer. Got the full sum? Okay. The next question which is given over here is 8.6. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. So 18 is initial, 36 is final in 5 seconds. Acceleration and distance covered again. So again put down the data over 8.6. 18 km per hour will become 5 meter per second because you are multiplying it by 5 by 18. 36 km per hour multiplied by 5 by 18 will give you 10 meter per second, and it is taking place in 5 seconds. So v minus u upon t, if you do, it will be 10 minus 5 upon 5 gives you 1 second, 1 meter per second square. And now distance will be v square minus u square. Always this formula will be easier. V value is 10, u value is 5. So 10 square minus 5 square upon 2 into a value is 1, which you have calculated. So 100 minus 25 is 75 upon 2, that comes to 37.5 meter. Okay. The third illustration which is given over here in this section is a brake is applied to a car and it is producing an acceleration of 6 meter per second square in the opposite direction. Opposite direction means this value is to be taken negative. Okay, acceleration is negative, means retardation hua hai. And it takes 2 seconds for the car to stop, means final velocity becomes 0. Initial velocity is not known, but finally it will stop. Calculate the distance traveled during this time. Okay, so S value is asked. So what will you do over here is, your A value is minus 6, remember, acceleration in the opposite direction, so negative. Time period is 2 seconds. In 2 seconds this change takes place, and a vehicle comes to a stop means final velocity is 0. So distance is asked. First of all, you will calculate the initial velocity. V is equal to u plus at formula. In that 0 is equal to u plus minus 6 into 2. Minus 6 into 2. So you will get 0 is equal to u minus 12, and that is u is equal to 12. So this is initial velocity. Now if you want to find the distance, v square minus u square upon 2a, which means v square is 0 square, u square is 12 square, so 0 square minus 12 square upon 2 into a. What is the a value? Minus 6. So 2 into minus 6 is minus 12. 2 into minus 6, 2 minus 6 nahi hai, 2 into minus 6. So minus 12 and minus 144. This minus is not squared. 12 is squared. This is subtraction sign. So minus 144 upon minus 12 will be 12 meter. Got these 3 illustrations very clearly? 8.7 also. Okay. So now based on it, you are having 5 sums are there. Let us very quickly take up those 5 sums on page number 109. A bus starts from rest. Starts from rest means u is 0, and it moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. So acceleration is 0.1 meter per second square. Timing is 2 minutes. You have to find the speed required, means final velocity. Because rest mein se aa raha hai to u 0. So final velocity is asked and the distance traveled. So this is how you put up the data. U is 0, A is 0.1, timing is 2 minutes, yani 120 seconds here. 2 minutes means 120 seconds. Now you have to calculate the V value. Speed required and the V value. V is equal to u plus at. Substitute the values. 0.1 into 120 will give you 12 meter per second. And S is equal to ut plus half at square I took because u value is 0. So u into t will be 0. So I wrote 0 plus half into a value is how much? 0.1 given. 0.1 into t square is 120. 120 ka square. So this is 0 only. Half into 1 upon 10. So half into 1 upon 10, 120 into 120. Now if you solve this complete thing, you will get 720 meter. Understood the first sum on page number 109? Okay. The next sum you have is on page number 110. The sum says a train is traveling at a speed of 90 km per hour. Brakes are applied so that there is a uniform acceleration of minus 0.5. Uniform acceleration of minus 0.5, or you say acceleration opposite direction 0.5. Find how far the train will go for it to come to rest. Come to rest means this is initially it is moving at this speed. So initial speed, finally it is going to become 0. And then how far? Distance is asked if the acceleration is this much. So the second sum, here it is given to you. U is 90 km initial. So multiply by 5 by 18, you will get 25 meter per second. Finally it will come to rest 0. Acceleration is minus 0.5 meter per second square. Distance is asked. So v square minus u square upon 2a. Substitute the value. V is 0 minus 25 ka square upon 2 into 0.5. This is not 2 minus, 2 into 0.5. 2 into 0.5 means minus 1. Okay, 2 into 0.5 is 1. So minus 1 upon minus 625, because 25 square 625 and this negative sign is a negative, upon negative will become positive. So 625 meter the vehicle will come to a stop. Next sum. A trolley while going down in an inclined plane has an acceleration of 2 centimeter per second square. What will be its velocity after the start? After the start means start अगर करना है यानी rest में था, so initial is 0. So now 2 centimeter per second square has to be converted into 2 meter per second, into meter per second square. So it will become 0.02 meter per second square. So after 3 seconds, that is timing 3, what will be the velocity? Final velocity पूछा गया है. So here you have it. 2 centimeter per second square will become 0.02 meter per second square. U value velocity is 0. Timing is 3 seconds. V is equal to U plus AT. So substitute 0 plus A value is 0.02 into time is 3. So it will become 0.06 meter per second. Clear till here? The fourth sum. A racing car has uniform acceleration 4 meter per second square. What distance will it cover in 10 seconds after the start? Again after the start का मतलब initial is 0. What distance will it cover? Directly distance is ours. Velocity is not required. And initial is 0. So here you have it. 4 meter per second square is the acceleration. After 10 seconds it is achieving, and after the start means U value is 0. So S value will be ut plus half at square. Since U is 0, this first value will become 0. U into t will be 0. Half into at square, half into 4 into t square is 10 ka square. So it will become 200 meter. Clear? The last sum in this section on this 110 page is: a stone is thrown upward with a velocity of 5 meter per second, means that is the initial velocity. If the acceleration is 10 meter per second square in the downward direction, डाउनवर्ड डायरेक्शन पॉजिटिव 10 होता है, ऊपर जाते हैं तो -10 होगा. What will be the height attained? What height attained means distance covered, and how much time will it take to reach that height? So stone is thrown upwards. Initial velocity is 5 meter per second. The acceleration due to gravity and the acceleration is 10 only. But when it is moving upwards, it will be -10, and when it is moving downward, it will be +10. Timing is asked, distance is asked. V is equal to U plus AT, but since it is thrown upwards, the A value will be taken minus. So 5 plus minus 10 into T is equal to, when you are throwing anything upwards, the final velocity when it reaches up will become 0. So -5, this 5 comes over here, -5 is equal to -10T, so T will be -5 upon -10. That will become half, that is 0.5 seconds. That is the timing. And now the distance. S is equal to V square minus U square upon 2A. Your V value is 0. U value is 5. So 0 square minus 5 square. 2 into what is the acceleration upwards? -10. So -5 ka square any -25 upon -10 into 2 will be -20. That will come to 1.25 meter. Clear so far? The last part in this particular chapter is about uniform circular motion. When any object is moving in a circular path with with the speed being constant, then it is said to be a uniform circular motion. Okay, that is defined over here. If an athlete moves with a velocity of constant magnitude along the circular path, the only change in its velocity is due to the change in the direction. Means speed is same, but direction is changing, so the velocity is changing. Okay, so such a circular path, when the person is moving, it is said to be uniformly accelerated motion. The movement of the planet around the earth is also uniformly accelerated motion. Okay, because the direction is only changing, but the speed remains the same. The velocity in magnitude remains the same. So when an object is moving in a circular path, the distance will be 2 pi r, circumference. So if you want to find the speed, the formula will be distance upon time, but distance of the circular path will be 2 pi r upon t. So when an object is moving in a circular path with uniform speed, it is said to be uniform circular motion. So that is the definition which is asked. Sometimes this may be put up, what is uniform circular motion and what is its formula. So that is explained in this much part. With this, your chapter is over. Now the exercise sums which are left that I'll take up in the next video. Okay, so your homework from this part will be you work out the blue questions which are given on page number 109 and 110 that I discussed just now. Is that point clear? Okay. Thank you.